Let's go through Liquid 1834 single thread CPU. So it gives us a two-dimensional array tasks. And for each element, the task have two integer in it. The first integer is a task in queue time, and the second one is processing time. So I say this task, if we start at in queue time, it will end with in queue plus processing time. So we're giving a single-threaded CPU that can process at most of one task at a time. So if the CPU is idle and there is no available task to process, the CPU remains idle. And if the CPU is idle and there are available tasks, the CPU will choose the one in this kind of order that if you choose the shortest processing time, if multiple tasks have the same shortest processing time, it will choose the task with the smallest index. So um, return the order in which CPU will process the tasks. So let's look at the example. The task at time one, this task 0 is available. So we'll process this, and it will finish at time 3. And during at time 3, we'll see the task 1 and 2 are available. We'll choose the one which is smaller processing time. So we'll choose 3, 2, this task. So um, it will add to 3 3 because this one is finished at time 3, right? So at time 3, sorry, we have 2 and the task 1 and task 2 are available, right? So we're choosing the one which has the smallest processing time. So we will choose this one. It will finish at time 5. At time 5, the 4.1 and 2.4 are both available. We choose the shortest processing time, that's 4.1, right? So we'll choose index 3 and then index 1. So it will need us to return the order to process all of these tasks. So for this question, apparently we need to sort the task, right? And sort by the in-queue time. But if we sort, the index will change, right? So of course we need to recompose the arrays to add the index, then sort. And we need a priority queue, which is possibly the jobs to do at some kind of specific time spot. So this kind of priority queue will be a min heap. So it will have the comparator first compare by the processing time, then compare the index. So we need a time variable, which means the current time, right? And also we need possibly an TID, which will be the task or the array which we have index with the task ID, right? So we will write while the index is smaller than this length, we're trying to write our coding logic. So we iterate this ID of the tasks, which is sorted by the in-queue time one by one, right? So what we do is that we firstly should check whether the to-do queue is empty or not. If it is empty, our time should be the TID next to the task to do the in-queue time, right? So we'll update our T variable to next to do tasks in queue time. And then what we do is that we are because it may have multiple tasks at the same in queue time, right? So we'll put all of the tasks which can do to the to do queue, and also put those kind of TID, the array ID increase, right? Then what we do is that we just pull the item from the to-do queue and also update our result. And after update our result, our time will also be updated, right? Should be changed to this task finish time. So should add this processing time for this task. So doing like this process will have our result. So let's write a code for this. And because the first thing what we want is that we need to have index I with these tasks, right? Then we compose an array equals new int n3, right? So what we do is for int I equals 0, I smaller than n, I plus plus, array I 0 will be equals task I 0, and the array I 1 equals tasks I 1, and the array I 2 will be the index. So then we need to sort, right? Arrays sort array. We just need to sort by its in-queue time, right? So what we do is A, B goes to integer compare A 0, B 0, right? And we need a priority queue, which is able to do, right? Called to do queue. Just at any time, specific time queue. So we'll say at a time t, if there are multiple tasks is available to do, right? We should compare its processing time first, and then compare its index. So we are going to have A, B goes to if A1 equals, if its processing time equals, right? Then we are going to compare its index. Otherwise, we're going to compare its processing time. So we need a t variable, right? Means the current time. And also we need a task ID because we want to have all of the task items to be put on our result. So this TID is index in array, right? So what we do, we need a result equals new int, and what we do is that for int I equals 0, I index. You can use I equals 0, right? I smaller than n, I plus plus. So what we do is that we'll check if to do queue is empty, then we're going to have t equals max t and array tid and 0, right? So means the next available time. And for this kind of in-queue time, right? Uh, it may have multiple tasks will be in queue, right? So we'll write while TID is smaller than n and array TID 0 is smaller than T, smaller equal, right, than T, then we're going to do Q, we're going to offer array TID. And also we have TID should increase, right? And now our T is will be our time, right? When once we run this while loop, that will have at least one task to execute, right? So the task we are going to execute is we are going to pull from this to-do queue because it's possible it's more than one, right? So we're going to have a task equals to-do queue dot pull, and we're going to have update our result will be task two, right? And also we should have our T will change to because we are processing this task should add it to its processing time. So in the end, we just return result. Okay. Doing like this, the time complexity will be O n log n, and space will be O n. And we can also write a Python code for this. So we're going to have n equals length tasks, and we're going to have array equals this one task I 0 task I 1 and I for I in range n, right? So we're going to have array source t equals lam uh, x x 0, right? We need a min heap to do Q, right? Equals this one. So we know we are going to have it will be sorted by processing time and index and in queue time, right? So what we do is, and let's have a result equals this, and we have TID equals 0, 0, right? Then what we do is that mm, for I in range, right? What we do is that if not to do Q, and T is smaller than array TID 0, right? So then we're going to update our T to be the next available task. And then what we do is that while TID is smaller than n and array TID 0 is smaller or equal to T, right? Well, in Q, all of the available tasks, then heap push to do Q and array TID 1, right? The processing time array TID 2, right? That is index array TID 0, the in-queue time. We don't care about the in-queue time, right? Then TID should plus equal to 1. And we need to have pop right? So we'll have processing time, and index. And the third one, we don't use it. We can use our underscore, right? Equals a heap, but a heap top to do here. Then we're going to have T should add to this process time, right? Oh, right. And the result should append this index. And in the end, just return result. Keep Q.